Hi, in this video we will do some examples for implicit differentiation, and we will have some examples actually to find the second derivative using the implicit differentiation. So here we have the function, the equation. We start always implicit differentiation by differentiating both sides of equation with respect to the independent variable. Here the first one is derivative of tan y. We have to use the chain rule, and the derivative of tan is secant squared equals, this side we need the chain, the product rule, y prime e to the power x plus y times derivative of e to the power x, which is just e to the power x. Then we have an equation for y prime. Let me first write this guy is just e to the power x. Then we have an equation in terms of y prime, and we can solve it by separating it. Means that bring all the terms which has y prime to one side and factor y prime and then divide the multiple of y prime. You find the y prime. Well, in terms of x and y, but doesn't matter here, just you find y prime. Okay, the second example, it says find the tangent line to the curve given by this equation at the point 0, 1. First thing to check that 0.01 is on the curve. Means what? Means that when you plug in x equal to 0 and y equal to 1, the equation is satisfied. And as you can see, this is sine of 0 equals to 0 plus 1 minus 1, which is 0 equals to 0, and that means yes, 0, 1 is on the curve. Now we need to find a slope of the tangent line, which is dy dx, or y prime, when x is equal to 0, y is equal to 1. Means that we have to find the derivative of y, and since this is just an equation in x and y, we need to do implicit differentiation, which starts by differentiating both sides with respect to x. Here I have xy prime cosine of xy, and on the right hand side this is 2 plus 2y prime y minus 0. Here we have a product rule, so it will be 1 times y plus x times y prime times cosine xy equals to 2 plus 2y prime y. Well, if someone would ask you to find the derivative, you will go ahead and find y prime out of this equation. But now we want to find the value of y prime at x equal to 0 and y equal to 1. So this would make life easier if we plug in 0, 1 at this stage and then find y prime. You see right away how this simplifies things. This will be 1 plus 0 times y prime cosine of 0 times 1 equals to 2 plus 2y prime times 1. This is 1 plus 0 times cosine of 0. Cosine of 0 is 1. So we have 1 equals to 2 plus 2y prime. Solve this thing, you get 2y prime is 1 minus 2, which is negative 1, and y prime is negative 1 over 2. We found the slope. This is negative 1 over 2, and we have a point. The point has components x1, y1. Then we can write the equation. An equation for the tangent line, y minus 1 equals to negative half x minus 0. So y minus 1 equals to negative half x, and y is equal to minus x over 2 plus 1. That's the equation for the tangent line at that given point to that curve. Let's go to the third part. We are trying to find the second derivative. So this is the same thing as y double prime. The key point here is that y double prime is the derivative of y prime. So if you find y prime, differentiate it another time in terms of x, you will get y double prime. Here, since the equation, we have equation in x and y, we have to make sure that to find y prime, we have to do the implicit differentiation. This is how we start. Differentiate both sides with respect to x. Then apply the chain rule whenever you need. And then solve it for y prime. This will be negative 2x over 2y, which is minus x over y. Let me write it here. Y prime we found is negative x over y. Now we want to find y double prime. Means what? Means you have to differentiate y prime, okay, with respect to x. Y prime with respect to x means that you differentiate minus x over y with respect to x. This is quotient rule, yes. A minus derivative of numerator is negative 1 times y is negative y minus negative x times derivative of the denominator over denominator squared. This is minus y plus x y prime over y squared. You will say, okay, we found y double prime. This is minus y plus x y prime over y squared. But you're not supposed to have y prime in the formula for y double prime. You can have x and y since the function is given implicitly, but you cannot have y prime. Well, solving that is not difficult because we can write using this, you can write, replace y prime by something in x and y. Yes, so y prime, instead of y prime, I plug the minus x over y. And now you can simplify this thing. This will be minus y minus x squared over y squared. You simplify a little bit more. Y squared minus x squared over y squared. Oh, y cubed. Because this y, we found the common denominator. That will go down. First find the first derivative and then differentiate it again. Let's do this other one. So we'll start with differentiating the equation with respect to xy, because this is how we find y prime using implicit differentiation. This gives us x plus y prime cosine of x plus y equals to 1. And some rule says 1 plus y prime cosine of x plus y is equal to 1. And well, you can solve y prime. Divide this guy cosine of x plus y and take this 1 to the other side. We know that 1 over cosine is secant. That's just a name for 1 over cosine of x plus y, which is secant x plus y. So we found y prime is a secant x plus y minus 1. Now we want to find y double prime, which is derivative of y prime, and that means that we are trying to find derivative of secant x plus y minus 1. This is what? This is secant of something. So the derivative of that something times secant of that tan of that. Remember, derivative of secant x is secant x tan x minus 0. So we almost found it. This is this part, sum rule, 1 plus y prime times secant x plus y times tan x plus y. Y prime is there. We have to get rid of that by plugging in this guy there. So y double prime is 1 plus secant x plus y minus 1 secant x plus y tan x plus y. This one and that cancel out, and we get secant, you see, secant x plus y times secant, this will secant squared x plus y, and then tan of x plus y. That is how we found the second derivative using implicit differentiation. Okay, so you have to know how to apply the implicit differentiation, in particular if someone asks you to find the second derivative of y with respect to x through the equation.